Hello and welcome to this conference. My name is Mira Kuchibuza Marcel, and I'm the founder and the director of the Pan African Citizen Science E-Lab. So, in this conference, I'm going to be talking about empowering African youth in astronomy, the impact of the Pan African Citizen Science E-Lab. And here is my picture right there. So, in the table of context, I'm going to be talking about PACS Lab, then key project, then results, and the future goals. So PACS Lab was founded in December 4th, 2020, and our aim is to promote hands-on activities in astronomy and space science through citizen science and soft astronomy research in Africa as a means of advancing space exploration and enhancing space education and outreach. And we do that by collaborating with entities in the global north and bringing those opportunities down to Africa. And for now, all our activities are based online. So here is our WhatsApp group where we interact and exchange information. And here is the map of Africa showing individuals with their computers analyzing and contributing data to the scientific research. So for the general requirement, all our projects are suitable for all individuals regardless of age, religion, country, sexual orientation, academic or professional affiliations or levels. So what we only require from you is to have a basic computer operation knowledge like Windows operating system, have access to internet and have passion for space and astronomy. So for our basic project, we have primary project and we have secondary project. So in our primary project, we have asteroid search, we have exoplanet and photometry, we have research writing on double stars, then we have ARIES and many more. We keep adding more projects. Then our secondary project, we have telescope giveaway. I'm going to elaborate on each of these projects. So on the Pan-African Asteroid Search campaign, we search for asteroids and we collaborate with the International Astronomical Search Collaboration. We're the biggest partner in Africa. So here we discover new asteroids and contribute to the planetary defense to avoid events like this. And how we do that is by analyzing data. We do not generate our own data. We analyze data with the astrometrical software. And here is how to detect asteroids in the software. So the data we use for asteroid search are gotten from the Pan stars and the Catalina sky surveys. These two generate the most asteroid data in the world as shown in this chart. So after that, the data is sent to Isaac. Isaac is responsible for distributing the data across the whole world, across entities in the whole world, and we happen to be their biggest partner in Africa. So we are engaging different organizations in Africa in this project. So here is just one of our partners, the Amateur Astronomy Libya. So this team, they have a page on Isaac website under the Pan African Asteroid Search. So that is where they download their data, analyze the data, and submit it back to Isaac through this website. So for the general tools, we use Windows operating system, internet, and Astrometrica. And for training, we have video recording in English, French, and Arabic. And we also offer online training for our citizen scientists. So here are the video recordings, and here is the one of our online training uh, activities. So far, we have discovered up to 32 asteroids, and these discoveries were made by about 60 of our citizen scientists, and we have about hundreds of preliminary discoveries that are still undergoing further evaluation. So here is our calendar for the 2024-2025 academic year. So we are currently at October 2025 to November 19 Astro Research campaign, and it runs till May. So it runs every month. So our other project is the NASA Exoplanet and Photometry project. We are collaborating with NASA Exoplanet Watch Research Group on this project, and we are using to engage Africans in exoplanet research. And what we do is by refining the mid-transit time of already discovered exoplanets so that we can make their period to be accurate for future missions like the James Webb Space Telescope. And here is the light curve of one of the exoplanets we reduced. We use the exotic program for image reduction, and afterwards we submit the data to the American Association of Variable Observers. So here are the sources of our data. We get data from the NASA website, and we also use the Los Commerce Observatory to make observations. Okay, we are one of their partners. We are one of the partners. That we also use the Micro Observatory for scheduling and getting data. This is how we do that. This is just a fast forward demonstration how we do this. We schedule observations and we get images. So we actually train our citizen scientists on how to do this. So here is the tool. Any operating system, internet, Gmail, all software we use is online. And for the training, we have recorded videos and we have online training via Zoom. So here's some of our recorded videos. So we have Double Star Research, and we collaborate with Dr. Richard Fried, the president of the Institute for Student Astronomical Research. And what we do here is we engage our citizen scientists in double star research in order to update their position angle and separation. And the reason for we are doing that is because we want to make Africans to contribute to scientific research. And after that, they write up papers about their findings and send it to the Journal of Double Star Observers, and afterwards they get published. So for the training, we have recorded videos and online interaction with the research instructor. So we can use any operating system. We use internet, Astro Imager, and even have to Global Access. So this is our latest project, the radio contact with ISS, and we're collaborating with amateur radio on the International Space Station. So in this project, we're going to engage our citizen scientists are going to be interacting with astronauts aboard the International Space Station. So the reason why we do that is because we want to make these projects accessible in Africa. Okay, so recently we guided our group members on how to apply for that so that they can to also host it in their own countries. So we are getting ready to host this program starting from January 2025. So in the astrophoto visual development, we educate our citizen scientists on how to combine space images in the red, green, blue to produce colorful visual, and we train on how to get the data from the Hubble Space Telescope, the James Webb Space Telescope, and the Los Observatory for data for these kind of activities. So we have training methodology, we have recorded videos and online training via Zoom. So here are our recorded videos. We have for Photoshop, we have for GIMP. Photoshop is now free, GIMP is free. So then we know we are working with a lot of groups across Africa, and some of them are in their need of telescope for astronomy outreach and the teachers training program. So we collaborate with AFERS and Jean Pierre Grodet to distribute telescope to our astronomy groups, team leaders for this purpose. These are our teams from Uganda, from Malawi, from Lesotho, and we have even given more telescopes. So, so in this project, we collaborate with the Lesotho Webb Telescope for live observation. We use their telescope um, for live observation. So here is the dome. We use it to observe the moon, the sun, deep space images, and even the eclipse. So here are some of the images captured during the April 8th eclipse in North America. It was happening in North America while we were here with the slow telescope in Africa observing them. So, so here is the telescope site of the slow telescope. They have telescopes in Chile, in Canary Islands, and Australia, and they also have mobile telescopes to move around for events like eclipses. So for the result, we give out survey forms for our citizen scientists to fill and to express how they feel about our project. So far, we recorded about 691 citizen scientists. By the way, this was done on August. So from August to this November, the number has actually increased over 1,000. Okay, so and we have covered up to 45 countries out of the 54 countries in Africa. And then we have about 70 groups because we work with groups, we don't work with individuals. Now, we also divided these groups into different subgroups. For instance, the group A corresponds to, they are 15 in number. They correspond to national entities like national space agencies, national astronomical societies, national observatories, and other national entities. Then Group B are 25, and they correspond to university groups, and C corresponds to private astronomy organizations and private and secondary schools. So, in terms of gender, from the survey, the the entries, we are mostly male and female, although we are open to other gender identities. Then we have level of education. We have secondary schools, we have bachelors, we have masters, and we have PhDs. So from this chart, you can see that the bachelors are the most. So everybody is participating. The PhDs are mostly university teachers incorporating our project into the classroom to engage on the graduates. So our project, if you from this chart, you discover that the asteroid search is the one that has the most participation, and the reason is because we started out PASCI lab with the asteroid search. We recently incorporated others, and we are still just spreading them. So here is the year of participation showing the recruitment. So since 2020 that we started out, the number has been increasing every year by year. So, and here you see 2024, the number has actually increased, okay? Just that the time we did this survey, the recruitment was low, but now it has actually surged higher than all of these combined. So here is the geographical location. Africa has about 5 geographical locations: North Africa, West Africa, Central Africa, East Africa, and Southern Africa. And you can see that we are focusing around the region. We are not leaving any region unattended to. So here is the map of Africa showing the countries in blue. Okay, the countries in blue are the countries that we have a group that we are working with right now. Okay, so almost all the countries are already in blue color. Okay, so those are the ones we haven't really found somebody, but we are still looking out for people. So we crossed paths with Frank Machis, and he donated telescope to citizen scientists across the globe for contributing to citizen science research. So he promises going to be donating 5 telescopes to us, to support our activities, and so we intend to distribute these telescopes across our groups in the continent. Okay, so we plan to use the telescope for continued exoplanet studies, asteroid confirmation, astrophotography, and other observations. So here, this is just our future prospect anyway. Then in our second future prospect, we want to have a center, the PASC Lab Center for Astronomy and Research, for astronomy research, education, and outreach. So this is going to serve as a headquarters for PASC Lab, where we'll be coordinating our activities. So we have written papers on all of these things I've said here, and even more that I did not say here. So if you go over to our website, if you go to the publication, you should be able to see the publications. For now, we have published it in the ARXIV archive, although it is still undergoing peer review by journal. So you can reach out to us. You can reach out to us. We are seeking for support. We are seeking for collaborators, and also if you want to adopt our project, you can reach out to us. We'll be happy to collaborate with you. Thank you, and thanks.